We are going to start by 3 notes today. Before we begin, you should have this Chapter 5 proof reasonings list. You get it for your test and your quizzes and everything. We are adding things today, but this is a reference that you should always be able to go back to as you are doing proofs. The notes and homework are the exact same thing. It's quite long, but that's okay. There are 10 questions, and I'm going to do over half of them with you, and then you'll be responsible for the other half. Okay? Let's go ahead and sort of just review. We have addition property of equality. That's when you add something to both sides. Multiplication property. That's when you multiply or divide something to both sides. Symmetric property of equality. That's when you have to flip-flop. Say it says x equals 3, we have 3 equals x. Transitive property of equality. That's when 3 things equal each other. Substitution property, when we plug something in for something else. Distributive property is when we distribute. We have reflexive property. That's when triangles have shared sides. Definition of bisector, that's when you have a bisector that's just cutting an angle in half, so the angle would be split in half. And we will use that today. We will also use reflexive property today. And then we have definition of midpoint, which is when you have a midpoint and you can cut a segment in half. And then vertical angle theorem. Okay, those are going to be our main ones we use today. It's reflexive property, definition of bisector, definition of midpoint, and vertical angles. So let's go ahead and jump over here to our notes. Whatever's in the given, that's where you'll start. So it told me in the given that AE and BD bisect each other. That's given. Okay, bisect means to cut in half. So if AE cuts in half BD, that means that C is the midpoint for both of them, right? So cutting in half means to split the 2 in half. Midpoints, just like we did median in a triangle last chapter, it will split it in half. So it splits AE in half, so they get 2 tick marks. And it splits BD in half. So now they get a separate set of tick marks. Okay, if I mark it, then I have to write it down. So step 2. What did I mark? I marked that AC is congruent to segment CE or EC. Doesn't matter which way we write that. So CE. And why could I say they were congruent, right? Well, it's always in the given is my example here. So it said AE and BD bisect each other. If you look at your reasoning list, there is one of them that refers to definition of bisect or definition of bisector, which is the reasoning here. Okay? I not only said AC is congruent to CE, but I also said that BC was congruent to DC or CD. We can write it either way. And again, I knew that because AE and BD bisected each other, so it is also definition of bisector. All right, from last class, we also learned that I can mark specific things like reflexive property, a shared side, or a shared vertex, or parallel lines with alternate interior angles. This example, if I were to highlight both triangles separately, so I always suggest highlighting them different colors so you can see what they share. They share C. And if they just share a vertex, that is called vertical angles. And we know that vertical angles are congruent. From chapter 1, 2, 3, 4, all the way up to 5, we've talked about vertical angles. So if you mark it, we have to write it. So step 4. I can't just say angle C is equal to angle C, because then you can't clarify like what angle C actually is. So we have to use 3 letters to label angle C. So from chapter 1, man, that's been a while, right? We have angle ACB. And remember, the vertex always has to be in the middle. So if you'll notice, C is in the middle. So ACB is the top one, is congruent to angle. Okay, I went from A, then there was 1 tick mark C, and 2 tick marks in B. So I'm going to need to start on E, then go to C, then go to D. So angle ECD. And I knew those were congruent. How? That's the question you need to keep asking yourself because of vertical angle theorem. Okay? Now, once your triangles have 3 markings, you can walk around the triangle and see what you have. So we have a side, an angle, and a side. And you have to make sure they match. So we'll look at the other one, side, angle, side. They match. So now I can finish my proof. So step 5, triangle ACB is congruent to triangle ECD because of side, angle, side congruency theorem. And that's your first big geometry proof. Don't let this discourage you. Like, you're not going to be great at this at the beginning, but you will get better, I promise. Okay? You will get better. All right, let's move on to number 2. Go ahead and write down your given. Notice the given is 2 lines, so I need to write all of that down. DH, segment DH, bisects angle BDF, and semicolon, angle 1 is congruent to angle 2, and that is given. Okay, just a reminder, you can only mark it if it says this equals this. Everything else in the given is just really a hint of what you can say is congruent. So in this example, the only thing I can mark is angle 1 is congruent to angle 2. So those are angles, so I'm going to give them arc marks. Okay? This guy right here, DH bisects angle BDF, that's a hint. So if DH cuts in half, remember bisects means to cut in half, angle BDF, remember the angles are always at the middle letter, so it cuts that angle in half, then I can say that angle D is being cut in half. So I need 2 arc marks on each side. Very similar to the top one, I can't just say that angle C is congruent to angle C, because then you're not identifying which side of the angle D is congruent to angle D. So step 2, with 3 letters, I would then say that angle BDH, so angle BDH is congruent to angle, okay, I started at B, then I went to D, then I went to H. So I need to start at FDH, so angle FDH. Because that one was in the given, our hint was that DH bisects angle BDF, the definition of bisect. Or bisector, there we go. Okay, each triangle only has 2 markings, so I still have to mark something else. If you guys remember from last class, if I highlight both separate triangles here with different colors, then I can really notice what is overlapping, what colors are overlapping. Do you guys see they share a side? They share side DH, and a side gets tick marks. So I don't have any tick marks yet, so I just need to add 1. So step 3, DH is congruent to DH. And that is because of reflexive property of congruence. And that may be a new one for us. I don't know if we've went over reflexive before. But reflexive just means when something equals itself. And remember, they are going to be on the list of your reasons that you get for your cheat sheet for your test. Okay? All right, if I walk around my triangle, you're going to notice, just do one triangle. You have angle, side, angle. Check the other side. And they match. So now I'm ready for my proof. Step 4. Triangle BDH is congruent to triangle FDH because of angle, side, angle, congruency theorem. And once you've finished it and written exactly what it says, you are done. Okay, let's go ahead and go to the next one. All right, we always start with the given. So number 1, WX, segment WX is congruent to segment ZY. Those should be segments. That's a misprint. We need to fix that. Comma, segment WX is parallel to segment YZ. That is given. All right, so I can mark it because it says WX is congruent to YZ. It physically tells me they are equal. So those are sides, so I give them tick marks. But then it also says that WX is parallel to YZ. If you guys remember, parallel means arrows. So I have an arrow on WX and an arrow on YZ. I'm actually going to highlight my triangles already to start myself, give myself a good base of what they possibly share. Do you notice they share anything? Yeah, they share that side XZ, right? So side XZ is congruent to side XZ because of reflexive property of congruence. Okay, I have a little trick with parallel lines. So if you highlight your parallel lines, and then you highlight the diagonal line that's connecting the two, you should see a Z, either a forward Z or a backward Z that's created. And the corners of those Z's are the alternate interior angles. So if you look at it, you're going to notice that we have alternate interior angles in this corner and in this corner. Parallel lines will always have, for our congruency proofs, either alternate interior angles or corresponding angles. So that's something we need to pay attention to. So step 3, I can't just say angle X because angle X has a bunch of angles. So we're going to say angle WXZ is congruent to angle YZX because of alternate interior angles. Okay, and now both of our triangles have 3 markings. So if I go around, I have side, angle, side. And I can check it, side, angle, side. They share that side, so I can say side for both in the middle there. So I'm ready. Step 4, triangle ZWX is congruent to triangle XYZ because of side angle side congruency theorem. That checks out. Awesome. Okay, you guys are gonna, your homework, one of your homework questions is number 4. So you'll need to try that on your own. And then I'm gonna do number 5 with you. Let's go ahead and write down our given. Our given is so long on this one, isn't it? So I have AE is parallel to BD. And AE is congruent to BD. And then also angle E is congruent to angle D. Holy cow, I have so many of these. And this is given. Okay, so I can mark off a lot of things here. I have AE is parallel to BD, so there's parallel lines. I have AE is equal to BD, and then I also have angle E is congruent to angle D. Okay, now this one is a little tricky because when you highlight your triangles, you're going to notice that they intersect at B, so you would think, well, B is shared, so I can mark it like this. That's not true because it's not the same angle on both sides, and they're not vertical angles. So I can't mark them because this is this side of the B, and this is the other side of the B, and they don't make an X. Like X would be vertical angles just like that. In this example, it's not. So even though B is where they connect, I cannot say that. Now I can use my parallel lines, but this one's a bit trickier, right? So I have my parallel lines. And then I have this shared side right here. Do you see any angles that connect with those parallel lines and the transversal that are the same? So if you notice, there are corners. This one's not a Z, but you still see corners. So angle A is congruent to angle B. Angle A is congruent to angle B. So step 2, I have to say angle EAB is congruent to angle DBC. And these are corresponding angles. So that was from chapter 2. And they're congruent. So corresponding angles that are congruent. Now, if you notice, I have 3 things on each side. So if I go around, I have angle, side, angle. And that's one of my congruency statements. Angle, side, angle. And it matches. So step 3, I am ready to prove this guy. So triangle AEB is congruent to triangle BBC because of angle, side, angle, congruency theorem. If you ever need to pause the video, please feel free to. Sometimes this one goes kind of fast. This is homework. Number 6 is homework. So just remember, if you don't have parallel lines and you just have a bisector, to go back to the questions that look like bisect and use your resources from questions 1 through 5 that you can best use those to help you solve number 6. Let's go ahead and look at number 7. Given D is the midpoint, ooh, new word, fun, new point, midpoint of AC, and I might have to do 2 lines with my given because it's quite long. AB is congruent to CB. All right. So reminder, we can only mark it if it says this equals this, right? So AB does equal CB. I can mark that. Awesome. This guy right here, where it says D is the midpoint of AC, that is a hint. And so you're going to really take that and you're going to think, if D is the midpoint of AC, what happens to AC? Remember, midpoint from even last chapter when we talked about it in median means to cut in half. Just like bisect. They are technically the same word. They mean the same thing. And so you just have to see what, most of the time a midpoint is a point, right? Or it is a point. where a bisector can be a segment or an angle, so that's why they use different words. But midpoint, to cut in half. So if it cuts AC in half, then AD is the same length as DC, right? And since I just marked it, then I need to go ahead and write it down. So AD, segment AD, is congruent to segment DC. And this one's new. It's not definition of bisector because the word bisect wasn't in the given. It's definition of midpoint. Okay. If I highlight my triangles right here, you're going to notice they share something. They do overlap. Does anybody see where they overlap? What do they share? They share side BD. So since I've already used one tick mark and I have 2 tick marks, this guy gets 3 tick marks. And since it's a shared side, you just say it equals itself. So BD is congruent to segment BD because of reflexive property of congruence. And then our last step is, since I have 3 things, and if I walk around, I have side, side, side. Check on the other side, 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 side. Everything connects, so it does work out. Step 4, prove it. Triangle ABD is congruent to triangle CBD because of side, side, side congruency theorem. And we are finished with number 7. Hopefully at this point it's starting to click a little bit. This day is always difficult because it's the first time you've seen those really big proofs. So again, don't get discouraged. Just keep going. This one is a part of your homework. So right now you have 3 questions for homework. Hopefully we have plenty of class time to work on them. Let's go ahead and slide over to the back page. This one is also a homework question. Number 9 is going to be a homework. So now you have 4 questions for your homework. But I am going to help you with number 10. Let's go ahead and write down the given. So the given is angle N is congruent to angle P, and segment MO is congruent to segment QO. Given. Neither of those were hints. They straight up told me angle N is congruent to angle P. So I can go ahead and mark those with arc marks. And they also told me that MO is congruent to QO. So those are sides. I can give those tick marks. There's some extra information on this picture that make it look kind of confusing. But if you look at the prove, it tells us what triangles we're trying to prove. So let's go and highlight those triangles. So I have triangle MON. And I have triangle QOP. So that triangle MOQ on the left, that doesn't matter. So we can just basically pretend that it doesn't exist. If you look at both of the triangles, they actually do share something. And they both already have 2 tick marks, so I really only need to add one more thing. They share angle O. Angle O are they're vertical angles. So I can mark them with 2 arc marks since I've already used one. Now, if you remember from questions, I think 1, 2, and 3, we couldn't just say angle O is congruent to angle O because they're 2 different triangles. So I need to be really careful here. I have angle MON is congruent to, so I went from M to O, which has 1 tick mark, and then O to N, which has an arc mark at the end. So I need to stay consistent. So I'm going to need to start at angle Q, then go to O, then P. And the reason I knew they were congruent is because they are vertical angles. All right, the last step, if I go around my triangle, I have side, angle, angle. And that is one of our congruency statements, side, angle, angle, or angle, angle, side. It's the same thing. You can write it however you want. So step 3, triangle MON is congruent to triangle QOP because of angle, angle, side, congruency theorem, or side, angle, angle. It's the same thing. Okay, you have 4 questions for your homework. If you get lost, just come in and ask. Proofs are always a little bit more difficult the first time you do them, but they do get better. All right, guys, have a good day. I will see you in class next time.